finding the volume of a sphere today. And look at that juggler. Wow, he's juggling a bowling ball, a watermelon, and a tennis ball. Well, only two of them are spheres. I'd like to see him juggle a watermelon and a bowling ball at the same time. That'd be pretty interesting. Alrighty, so what we're going to do to figure out this volume of a sphere is we're going to think about a sphere that can fit fully inside of a cylinder. So in class we will be doing an investigation, and I want you to notice that this is the smallest cylinder that can enclose this sphere, because the radius of the sphere, or better yet, the diameter of the sphere, is equal to the height of the cylinder. So that's the relationship we're going to use. And if you were in class, what you'd be doing is you get some rice and you'd pour it into a hemisphere and you'd fill it up. And what you'd find is that one hemisphere equals about 1/3 of the cylinder. So that means that one sphere, the whole sphere, equals 2/3 of the cylinder. Okay, but the question is, what's the volume of the cylinder? Well, we know that the radius of the cylinder is r, and the height is 2r. So remember, our volume formula is area of a base multiplied by the height. So the area of the base is pi r squared times 2r. So this volume is going to be 2r cubed times pi. So that's the volume of our cylinder. But what we know is that the sphere is 2/3 of the cylinder. So then the volume of the sphere is going to be whatever 2/3 of the cylinder's volume is. And we typically write this as like 2 pi times radius cubed. And 2/3 times 2 is 4/3. And that's about what we're going to do. That's going to be the volume of our sphere. So maybe you want to write it down as a formula or a conjecture. The volume of a sphere with radius r is given by V equals 4/3 pi r cubed. And that formula should make sense to you because the only measurement that a sphere has is the radius. So the radius goes in, the volume goes out. That's it. Okay, now it's time to play with some formulas. Pause the video for a minute, see if you can get those two volumes. All right, so in our first one, it looks like the radius is 6. So if the radius is 6, the volume is 4/3 pi times the radius cubed. And I think when we multiply 4/3 times 6 cubed, we get 288. But don't forget, we're going to leave our answer in terms of pi, so let's leave it as 288 pi. If you wanted to go to the nearest tenth, now you multiply 288 times the pi button on your calculator. Now this is pretty cool because this is a hemisphere. Have you ever heard of a hemisphere before? Yeah, we just talked about it about 5 minutes ago. Hemisphere is half of a sphere. So its volume then would be half of 4/3 pi r cubed. Let's see, 3 cubed is 27. Divided by 3 is 9. Times by 4 is 36. Divided by 2. We do all that, we should get 18 pi for our volume. So far, so good. We love it. Let's go the other way now. Let's find the radius of a sphere whose volume is 3053.6 cubic inches. Give it a shot. See what you can do. All right. So I'm going to use my volume formula. V equals 4/3 pi r cubed. Now I know my volume. So I'm going to plug in 3053.6 equals 4/3 pi r cubed. And we're going to solve for r now. So let's do some undoing of this equation. So on the right side, I see divide by 3. So that means on the left side, I'm going to multiply it by 3. So I'm going to get this 3053.6, and I'm going to multiply it by 3. Likewise, I'm multiplying by 4 on the right, so I'm going to undo it by dividing by 4. I'm also multiplying by pi, so I'm going to divide by pi as well. Now this is equal to the radius cubed. Okay, now this is interesting because you know how to solve an equation. Like if it was r squared equals 16, you would then take the square root of 16 to get 4. So you do a square root to undo squaring. How do you undo cubing? Well, if you guess cube root, you are correct. So the cube root is written this way. It's the cube root of a value. So I'm going to take the cube root of both sides of this. Let's see if I can squeeze in a cube root there. There we go. And that's going to mean then that my radius is equal to the cube root of whatever 3053.6 multiplied by 3, all divided by 4 pi, whatever all that is. And that's why I've got my graphing calculator out, to show you how to type all that in. So let's go over here to the graphing calculator and see how we can do with that. So here's where cube root is. Do you notice where the exponent button is? It's the one that's 2 to the left of the 4. I'm going to go Control and that button there. And it allows me to first type in what's called the index, whatever root I'm doing. So I'm doing the cube root of, and here's what I like to do. This is why these calculators are so cool. I am now going to do control division. And I'm going to type this in as a fraction. And this is why it's handy to do it this way. Whoops. 3053.6 times 3, that goes on top. And if I'm going to divide it by 4 pi on the bottom, notice that this calculation looks exactly like the one I'm trying to do here. So when I press enter, that's going to give you my radius. It's 8.9999. Let's round this up to 9. The radius is 9. Now, what I want you to be careful about is if you're not using the TI Nspire calculator, what you have to realize, I'll go back here, is that when you divide by 4 pi, make sure you put that 4 pi in parentheses. Because otherwise, I'm going to get a completely different value. All right? And that's why I like to do this as a fraction. If I did the cube root of 3053.6 divided, let's do times 3 divided by 4 pi, watch this. It gives me a completely different answer. Notice it took the pi and multiplied it. Either put it in the denominator or put parentheses around it to make sure that we get it right. All right, let's keep rocking. One last question here. So maybe if you take like a tennis ball that guy was juggling and you cut it in half, what I want you to notice here is that we know the diameter of the outside of this is 5 inches and the diameter of the inside is 4 inches. Ooh, so right away I need radii, right? So first of all, my radii for the inside is 2, and maybe the radii of the outside is 2.5, not 3, silly. Ooh, gotta divide by 2. Now, think of this as a volume of the big ball on the outside. So if I do the volume of the outside piece of this plastic, or was it plastic as a rubber or some plastic? Yeah. It's going to be 4/3 pi. Ooh, it's not even going to be 4/3 because it's half of it, right? So let's start this over again. Let's do half of 4/3, which is 2/3. I'm writing down the 2. 4/3 pi times 2.5 cubed. This is the volume of the outside of it. Now, that's not solid though. What I'm subtracting away from the inside has a radius of 2. So the volume of my inside is 1/2 times 4/3 times pi times 2 cubed. And the volume of this plastic is going to be the difference between these two. So my volume that I'm looking for is going to be, and can I do 1/2 of 4/3 and get 2/3 pi times 2.5 cubed minus 2/3 pi of 2 cubed? And you can type it all into your calculator if you want, but I'm noticing something. There's a common factor of 2/3 pi. So what if we type it in this way? 2/3 pi times 2.5 cubed minus 2 cubed. And no, that's not 0.5 cubed. But now let's go to our calculator and type it all in. So we'll do 2 divided by 3 times pi times, in parentheses, 2.5 to the third power, go to the right, minus 2 to the third power. There we go. Does my expression look like that one? It sure does. There's my answer. Let's round it to the nearest, I don't know, whole cubic inch. So let's say it's about like 15.96 and a whole bunch. So let's say 16 cubic inches. How'd you do with some volume today? Use that volume formula for spheres and for hemispheres.